Okay, so how to do PWM in STM32Cube. When I first started looking it up, I found there was not a lot on it, so I'm just going to show you guys how to do it. Very simple-ish. Okay, so File, New Project. I'm going to do it from scratch, so if you haven't tried Cube at all, you can see how it's done. So you start by opening it, you go File, New Project. If you're starting it for the first time, it'll give you that option. Come over to Board Selector. Type of board, the one we're using is a Nucleo 64. It's down the bottom there, F446RE. Double click that. I'm on Windows. I'm assuming it'll be roughly the same for a Mac. It's the same board. Should still work. Should be like this. Okay, so I'm going to clear all the pinouts, start from scratch. Okay, so first thing you got to do, come down to RCC, turn the high-speed clock to the crystal ceramic resonator, so that turns on the clock. Then you will use timer 1. There are quite a lot of timers. Each one has a few channels. I think most of them have a channel that corresponds to a certain pin. I'm just going to use timer 1 because I know it works. Some of the other timers might not have pin connections. So go to timer 1, ignore these three. I'm going to turn on channel 1. You're going to turn down to PWM generation for channel 1. And I'll use channel 2 just as an example of other stuff you can do. Okay, so each timer has a certain number of channels. Those channels are all different. So timer 1's channel 1 is not the same as timer 2's channel 1. So the channels belong to the timers rather than each channel having an option of belonging to a timer. So we're using timer 1's channel 1 and channel 2. Okay, next step is go to clock configuration and pay attention to this number here. That's the system clock, or the clock speed. It's in megahertz, and that's going out to the timers. So the timer's being run off an 84 megahertz clock. So don't change anything here, just remember that. Next, go to configuration. Don't worry about these, just click on timer 1, which is active now because we turned it on. Go to parameter settings. So, the prescaler. Two important things are the prescaler and the counter period. The prescaler is a way of reducing the initial clock so the counter doesn't have to go all the way up to however many megahertz, because each one can only go up to 65,500. So the prescaler, I'll set that to 21,000. What that's saying is for every 21,000 of the main clock ticks, the counter's going to go up one. So we've effectively divided the main clock of 82 megahertz by 21,000. So if we then make that 4,000, then for every 21,000 clock pulses, the counter's going to go up by 1, and for when the counter gets to, when the counter gets to 4,000, it's going to reset. So we've effectively divided the main clock by 21,000 times 4,000 is 84 million, which is 84 megahertz. So we've turned that 84 megahertz into a 1 megahertz clock. 21,000 and 4,000 is arbitrary. It could have been, for example, 42,000 and 2,000. This number doesn't matter too much, but the important thing is neither number can go above 65,535. Okay, but this is important for working out the duty cycle. So next, ignore all this stuff, come down to the two PWM channels. The pulse controls the duty cycle, so a pulse of 0 means it's off the whole time. If I change that to 2,000, so these numbers aren't a representation of time at all, they're just like multiplication and division, or ratios. So if this counter is counting up to 4,000, then if the pulse is 2,000, that's going to be half of that, so it's a 50% duty cycle. Then channel 2, let's make that 1,000, which is a quarter of 4,000, so that's a 25% duty cycle. If you change the CH polarity, that inverts it, So if I make that low, I've inverted it, so this has now gone from a 25% duty cycle to a 75% duty cycle. So it's going to be off for that 1000, or for that quarter. Okay, and that's all we need to do there. Come over to GPIO settings, click on each one of these, and set the maximum output speed to high. Not sure exactly what it does, but every video I've looked at did it. I'll experiment with it after I've made this video and put it in the comments. Okay, may or may not need to click apply, but safer than sorry. Okay. Great. So now you go to project settings, give it a name, PWM test. And project location, remember this is the file that all your projects need to be saved in. This is for if you haven't used Workbench and Cube before. So just make sure it's a file. It could be in your documents folder or just anywhere, but make sure you only use the one file. If you use more than one file, it's going to be annoying for you. So yep, use that. And then set the tool chain to be SW thingy, the STM32 one. That configures it for System Workbench. Specifically, if you set it to something else, I don't know what code it's going to generate. That's all you need to do there. You don't know about that. Okay, so that generates the code. No, it doesn't. Got to go project, generate code. And it's thinking. Almost there. There we go. Now you can just go open project and it'll take you straight to the project in Workbench. But if you don't want to do that, or that doesn't work somehow, you go to System Workbench. You go File, Import, Existing Projects into Workspace, which is under General. Then you browse to that folder which you saved all your projects in. Click OK. Tick that. If something's already in there, like basic is, it'll be unticked. So just tick the one you want to bring in, and finish. And then it's all there. So your main is under src, that's all your .c files, and then your inc is all the .h files, so your headers. So go to main.c. So this is all, where's it going? So this is all code that's been generated for you by STM32Cube. So the hash includes, like Stephen said, you can only put code between the user code begin and user code ends. If you put it anywhere else, then if you change something in STM32Cube and regenerate code, it's going to write over anything you write. So if you put stuff outside of the user code begin and user code ends, it'll be rewritten unless you never use Cube again. So up here is where it creates a timer 1 handler for you. You'll need that in a bit. There's the main template where it does some initialization stuff. Then that. So this is where it configures all the clocks and sets the main clock frequency. Don't need to worry about that. Here's where it configures your timer. So this is where it sets the prescaler, that's where it sets the period. So all channels of any one timer have the same frequency. You can set different channels to have different pulse widths, or different duty cycles, not different pulse widths. You can set different channels to have different duty cycles, but they'll all still have the same frequency. So if you want to have multiple pins having different frequencies, you need a different timer for each one. What the channels can have differently is the pulse width. So this is where all both channels are configured. It sets the pulse width, then creates the first channel, then changes the pulse width for the second one. It also flips the polarity. So these things can all be different for the different channels. I don't know what most of them do, except polarity and pulse. So that's what's going on there. So then in your main, all you have to do is type 2 commands, one for each channel, which is that HAL underscore Tim underscore PWM underscore start. Use address of HTIM1, which is that thing it gives you at the start. So that's kind of like a timer handler. So you say HAL Tim PWM start, give it the address of that, comma Tim channel 1. So that starts the first channel going, and then then do it for channel 2 as well. Okay, once you've done that, you come up to the hammer, you go build the debug. And this will take a little while. Just going to pause. Hang on a sec. So that took about 30 seconds. The first one always takes the longest. Once you do it later, it'll be a bit shorter. Once you've done the debug, you build the release, which again will take a little while. I'll just pause it while it's working on that. Okay, so now both things have been built. So now we come up to the run button and we go run whatever you called your file. And as long as your board's plugged in, it'll give you that stuff. Wait, did that actually run? Yep, it's running. There we go. So now, I connected each one to an LED. Ah, you can't really see that, can you? Right, do that on its side. Okay, you can't really see it really well, but one of those is flashing. They're both flashing at a frequency of 1 Hz, once a second. One of them has a 50% duty cycle, and one of them is on for 75% of the time, so it has a 75% duty cycle. So yeah. So the important thing is, for setting the frequency, is the prescaler and the counter. They get the prescaler and the counter get multiplied together. Then the system clock frequency gets divided by what they're multiplied together by. So 21,000 times 4,000 is 84 million. So 84 megahertz gets divided by 84 million and gives you a 1 hertz output. And yeah, that is how you do PWM. And then it tells you which pins it's coming out of. And you can just look up Nucleo to work out what they are. Cool. That is it.